The last part of this standard is being able to graph those triangles or quadrilaterals on a coordinate plane and being able to find the perimeter and the area of those figures. So I just have three to show you. So I'm going to go ahead and plot these really quickly on the coordinate plane here. So -7, 1 is my A value, -10, -5 is my B, -4, 8 is C, and -1, -2 is D. Okay. Okay, so at this point, we are not really proving any of the shapes. That's another video or another part of this. We are really focused on calculating the area and the perimeter. So at this point, to find either the perimeter or the area, we need the side lengths. So let's go ahead and kind of make these triangles around here. And what you'll notice in this exact example is that all of my triangles, 2, 3, 4, 5, 6, have the exact same dimensions. So we can identify this as a square, which really tells me I only have to do this triangle or figure out this triangle right here one time, and then I know all of the side lengths of my square. So I'm going to use Pythagorean theorem, 3 squared plus 6 squared equals c squared. And when I do that, I get 45 equals c squared. And when I take the square root, I get c, or the diagonal is 6.7. So to find the perimeter, I would just do 6.7 plus itself 4 times. Oops. And when I do that, I get 26.8 units as my perimeter. When I calculate the area, remember the area is base times height, and it's where those right angles meet. So I would do 6.7 times 6.7, and that comes out to be 44.89 units squared. So recognizing what shape you have, predominantly squares and rectangles are what we're going to be doing for quadrilaterals. So recognizing, can I just find it one time, or do I have to find both sides, and then moving forward, understanding the difference between area and perimeter. So let's look at a triangle, and this one is a specific one because I would like to use the formula for a triangle 1/2 base times height in this example. So I've got -7, 1. I have -5, 10. That is not correct. And then I have 2, 1. So if I connect my vertices here, again, we're not trying to prove anything about said triangle. We are wanting to find the area and the perimeter. So if, again, if I want to find the perimeter first, I need to know the side lengths. When we have straight lines like the one at the bottom that are horizontal or vertical, we can just count. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this has a bottom of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. So to find this top one, I'm going to do 9 squared plus 7 squared equals c squared. And when I do that, that math is going to give me an 11.4 diagonal. I'm going to do 9 squared and 2 squared. And when I do that math, I'm going to get 9.2 as my diagonal. So for my, first of all, I can now say this is a scalene triangle. All of them are different. I am now going to add those three numbers together. So 11.4, 9.2, and 9. And when I add all three of those together, I get 29.6 units. From there, I want to talk about this idea of base and height here. So the base and the height always form a right angle. And we can really draw that right angle right down straight from the top of that triangle. Because we have a horizontal line, so if we can create a vertical line, we then would have the base and the height. And what's nice about those is that I can just count those. 1, 2, 3, 4, 5, 6, 7, 8, 9. So to find the area, I could absolutely use my height and my base and do 1/2 times 9 times 9, which is 40.5 units squared. So this trick is lovely. It just does not work for every single triangle. So I want to show you one where that does not work so you know how to handle that. So the last one of this video is, let me plot the points here, 2, 5. And then we've got 10, 9, and 6, 1. So let's go ahead and connect. We're going to make those triangles around each side because I don't have any horizontal or vertical lines here to help me. So this looks to be isosceles, and that's because I can see from my my two triangles here and here, they have the exact same length. So the hypotenuse is going to be the same. So 4 squared plus 8 squared equals c squared. That would give me that length, which ends up being 8.9 on both sides. And then 4 squared plus 4 squared would give me the bottom, which would give me a length of 5.7. So to find the perimeter, I would just do 8.9 plus 8.9 plus 5.7, and that would give me 23.5 units. Okay, so nothing new yet. But it is going to be difficult for us to come up with this length for a, I don't have a straight horizontal or vertical line to run a right angle with. And so instead, we're going to use the rectangle area and take away. Okay, so let's think about the larger area here on the outside. So we're looking at this right here. So this ends up actually being a square, has a length of 8 times 8. So we're going to start there and say 8 times 8 is 64. And then we are going to take away the 3 triangles that are not included. Remember, we want this inside area right here in red. So we want to take away the 3 purple-ish triangles. So to do that, we're just going to find the area of each one and subtract it. So triangle 1 has an area of 1/2 times 8 times 4, which is 16. Triangle 2, remember this one down here, it's the exact same triangle. 8 times 4, which is 16. And then triangle 3 here at the bottom, down here, is 1/2 times 4 times 4, which is 8. So the math we're going to do here is 64 minus 16 minus 16 minus 8. And whatever remains is our area of that red triangle, which in this case is 24 units squared. So kind of play around with that on those practice problems and take a look at, what method. If you have a horizontal or vertical line, draw a straight line down. It'll be fine. If you've got all diagonals, I would consider using this area model and taking areas away. As always, if you have any questions, always reach out.